So taking the integral with respect to y first, here you have integral -1 to 1, you get xy plus y squared, and y ranges between 2x squared and 1 plus x squared. Then we take the integral with respect to x. So here you have integral -1 to 1, and if you plug in 1 plus x squared, you get x times 1 plus x squared. Then here we have plus y squared, 1 plus x squared raised to the second power. Let me erase this part of the board. Minus, now we plug in the lower bound, which is 2x squared, x, 2x squared, plus 2x squared raised to the second power, dx. Okay, let us simplify this first. Here you have -1 to 1, and you get x plus x cubed plus 1 plus 2x squared plus x to the 4th minus 2x cubed minus 4x to the 4th dx. So let us simplify this first. We have x cubed, -x cubed, okay. And here we have 2x squared. We don't have any 2x squared, so let me write this guy down here. And here we get 3x to the 4th. Okay, perfect. So now let us take the integral. You get a half x squared plus x plus 2/3 x cubed minus x to the 4th over 4 minus 3 over 5 x to the 5th -1 to 1. Very well. So here you get a half plus 1 plus 2/3 minus a 4 minus 3/5 minus, now we plug in the lower bound, you get a half minus 1 minus 2/3 minus a 4th plus 3 over 5. So let us distribute this negative sign. We get -1/2 plus 1 plus 2/3 plus a 4th minus 3 over 5. Very well. Let's see. Can we simplify this? Yes, of course, because of symmetry. You could have seen it there. So a 4th, -1/4. What's left? You're left with 2 plus 4/3 minus 6 over 5. So the common denominator is 15. You get 30 plus 20 minus 18, which is equal to 32 over 15. Move on to page 5 to do the checkpoint for you. So on page 5, we have our checkpoint. This checkpoint says, find the volume of the solid. What solid? The solid that lies under the paraboloid. And lies under the paraboloid. What paraboloid? Z equals to x squared plus y squared, and above the region D, above the region D, in xy plane bounded by a line y equals to 2x, and also a parabola y equals to x squared. And parabola y equals to x squared. Well, let us take a look at the graph, see what are we dealing with. So we're dealing with these three, and note that it says above the region D in XY plane. So above the region D in XY plane. Here we have the information. Perfect. This is what we're dealing with. We want to find the volume bounded between these three. So there you go. Let us find the intersection between these two, because this actually forms our region D. Then you have your Z equals to X squared plus Y squared. Okay, so for the region D, you have the following. We have Y equals to X squared, Y equals to X squared, and we have, this is Y equals to X squared, and we have our line 2X. So this is 1 and 1, 2 and 4, for example. So now you have 2 and 4. So this is the point of intersection between them. As you can see, this is Y equals to 2X. So this is your region. Here we go. This is our region. As you can see, X squared equals to 2X. X squared minus 2X is equal to 0. So X is 0, X is 2, between 0 and 2. So you can set it up this way. You can say that, hey, I have the double integral. My X ranges between 0 to 2, and my Y ranges between X squared and on top 2X. And what is my function? My function is X squared plus Y squared, and I'm taking the integral with respect to Y first, then with respect to X. There you go. 0 to 2. We have X squared Y plus Y cubed 3. Y ranges between X squared to 2X, and you have dx. So let us simplify this first. 0 to 2. If I plug in 2X, I get 2X cubed plus 8X cubed divided by 3 minus, if I plug in X squared, I get X to the 4 plus, if I plug in this guy here, X to the 6 divided by 3, and then dx. I get 14 X cubed divided by 3, and here I have minus X to the 4 minus X to the 6 divided by 3. There we go. So these integrals is equal to, here you have 14 divided by 3 times 4, X to the 4, 0 to 2, minus 1/5, X to the 5th, 0 to 2, minus 1/21, X to the 7, from 0 to 2. So if I simplify this, I get 7/3 and 16 minus 1/5, 32, minus 32 divided by 21. Let's see. Let me just factor out 16. So I have 7 divided by 3 minus 2 divided by 5 minus 2 divided by 21. Okay. My current factor is going to be (105), so I have 16 105. 7 times 35 minus 2 times 21 minus 2 times 5. 265 minus 42 minus 10 divided by n. Remember that we are multiplying this guy by 16 over 105. Okay, here we go. We get 16. And here 255 to 113 divided by 105. Okay, let us do the calculator and calculate this. This is equal to 216 over 35. Remember that in this case, you can switch the order of integration. In this case, you get your y ranges between 0 to 2 and your x ranges between y divided by 2 and square root of y. So you could do that as well. Let's go to page 6, another checkpoint for you. Page 6. Page 6 says, find the volume of tetrahedron. Find the volume of tetrahedron bounded by planes x plus 2y plus z equals to 2. You have x equals to 2y, and you also have x equal to 0, 0 and z equal to 0. Let's take a look at the graph. This is our plot graph, so y is equal to 2x. Now here we have to switch this. 2y is equal to x. Then we have x equal to 0. Then we have z equal to 0. Let's add another object. And here we have x plus 2y plus z equals to 2. Well, so we're looking at the intersection of these. No restriction here. So when x is 0, your y is equal to 0, okay? Now let me just expand this so you can see a better visualization. Okay, perfect. Let me change the range. Okay, the intersection between these actually form a tetrahedron. Let's take a look at another graph. Okay, I hope you see this little tetrahedron. We just rotate this. You can actually see the tetrahedron as an intersection. This is the tetrahedron as an intersection of these in space. So if you try to visualize this, it's going to be like this. Suppose this is your x-axis. Here you have your y-axis, then you have your z. Very well. Let me use a different color for you. So it's going to be like this. It's going to be having a shape like this. So in XY plane, as you can see, you have a triangle. So let us just look at the projection in XY plane. So in x-axis, in y-axis, what do we have? We have this nice little shape here. So y is equal to x over 2. So suppose we're scaling this guy here and here. One and one. So when your x is equal to 1, your y is equal to 1/2. X is equal to 0. Okay, we're just projecting this into xy plane. You're looking at the projection. So when x is equal to 0, z is equal to 0, then your z is equal to, your y is equal to 1. Your y is equal to 1. Okay, this is 1/2. Okay. This is 0 and 1. So let's see, what else do we have? We know that x is equal to 0. When x is equal to 0, y is equal to 0. So these are the information that we have that helps us to actually visualize the projection. We can write equation of these lines by just connecting these points, y equals mx plus b. Very well, the first line on top is x plus 2y equals to 2. And the second line down there is going to be y equals to, you already have the information, x over 2. So your x's ranges between 0 and 1, and your y is bounded between x over 2. And you can say that, hey, I have 1 minus x over 2. Y is 1 minus x over 2. Perfect. So let's set up the integral. We are finding the volume. So in this case, we're using double integral. Remember that we can use triple integral. So here you have your function z equals to 2 minus x minus 2y and dy dx. My x is in between 0 and 1. My y is in between x over 2 and 1 minus x over 2. Here we go. So let us start taking the integral. So integral 0 to 1, 2 minus 2x over 2 minus x plus x squared over 2 minus, here you have 1 minus x plus x squared over 4. And here you have subtraction. So here you have minus x plus x squared over 2 plus x to the 4th over, x squared over 2. Okay, perfect. And here you have. So here you have -1 plus x minus x squared over 4. Let's try to simplify as much as we can. 2 minus 1, it gives you 1. Then here you have negative 2x, and here you can cancel out these two, negative 2x. So minus 2x. Then you get x squared, 2x squared over 4. X squared over 4, so you get 1x squared over 4. Then here you have x squared over 2. So if you add these two, you get x squared over 2. X squared over 2 plus x squared over 2 is just x squared. So this is x. We are taking the integral with respect to x. This is x minus x squared plus x cubed divided by 3. 0 to 1. So if I plug in 1, I get 1 minus 1 plus a third. This is the one.